So from this diagram, you can see the logic is pretty clear. The driver of this facade is some solar radiation analysis, or we call it solar analysis. Basically, the color, we can call this heat map, represent the intensity of the color, the intensity of the sun on the facade, right? So from the west to the source, you can see a very different kind of pattern based on the solar analysis. And also later, the student designed some kind of direct response to the solar. So here we can see the very high intensity light will basically result a panel with the smaller openings. But if you have lower solar radiation, then you have a bigger opening. Okay. So there are two questions actually I like to cover in this tutorial in Revit. So number one is how to generate solar analysis to generate something like this heat map. Okay, so that's first. Second question is what are the percentage of opening? Or you can call this as a window wall ratio we should choose. This is more kind of depends on your design. You could choose really large transparent openings if this is facing north, or if you want to block the sunlight from the west, then you choose a smaller openings, right? Or could be something parametrically controlled in Grasshopper. You can feed into this the heat map into the modeling process. If you recall in our earlier tutorial list, I gave you quite a few tutorials here. You can see the paneling system in Grasshopper, panel driven by image-based pattern making, right? This is all relevant to what we are doing. You can also see the earlier one is how to create a diamond paneling system controlled by an image, right? So what I really want to talk now, demonstrate is how to generate this image, the heat map, with a solar analysis in Revit. And also, second question is, what is the window wall ratio we should choose, right? From 0% to 100%, what would be the ideal, cutting line? All right, so that's a little bit concept. Just want to, follow up to this demonstration. All right. And this demo, I will cover first section is how to do solar analysis using Insight. Okay, so here if I go to the Analyze tag, and I have this option called Lighting and Solar. You probably don't have these options. This is a plugin for 2020. I think for the 2022, this is probably already embedded in Revit, but in earlier version, you have to download the plugin separately. And I put this plugin download page right here, install Revit Insight. Later, I will make sure this link is available in the tutorial, so you know how to install this Insight plugin. I think since 2016 is available, but you can definitely download, depends on which version you have. 2020 is the one. I think it's the oldest, but you can definitely download 2021, 2022, which already have the Insight. Okay, so after you install this program in Revit, you should see this tag available called Solar. So I will do a little bit demo how to use it. First, I have several geometries in this file. So I have, this is really simple wall, a roof, right? They kind of intersect to each other. Also, I have this massing model, right? So I'd like to do a demo for each type of geometry. Ideally, when you run the solar radiation, solar analysis, you probably don't really need a highly detailed model. What I mean is if you have stairs, railings, right? Probably you don't really need to care about that kind of detail. The only thing I want to, really do is the facade, right? Imagine if this is my building. If I switch to the massing, you can see it's a simple massing like this. It has a void inside, right? If I look around, it's hollow inside. And I have this massing, I cut a massing floor, so it's basically 2 levels high. All right. So let's start with the massing first. I will go ahead. Before I run the solar, I do want to identify the location. So here is a tag. You can click location button, and then I can define the location to Cincinnati. Well, it could be Atlanta, but I choose Cincinnati, Ohio, and then I click OK. Right. So this is the location. After you define that, then I can run the solar. Okay. When you click solar, you have this really simple window pop-up. This is a solar analysis supported by the Insight. And you can define how you want to load the surface into the simulation. So here I have the options to do all roof, all massing, or you choose selection. In general, I would prefer doing the selection because I know exactly which face I need. So I will choose user selection. Then I will just simply pick up, right, the massing phase. I like to do analysis. And then if you pay attention to this part of the toolbar, you have this finish. If I click finish, right, Revit will tell you you have 664 square meter surface has been loaded into the solar analysis. Okay. And you can definitely do reselect if something is wrong. Before I click update, I do want to make sure I set up a day, right? So here in the sun path, if you click, you can see a sun settings, and then you can define the solar information. So for instance, I only care about a single day, summer solstice, the hottest day over the year. And I want to define this from the sunrise to sunset, right? So this is the time range I like to do the solar analysis. Okay, so this is the basic info, and then I will click OK. So that's about the sun. Then I will go ahead, click this drop down, make sure you choose the correct type style. Also, if you want to export as CSV, you can set up here. In general, this is pretty straightforward. You should, just choose the default units. You usually want to do the cumulative insulation. This is the most common one. For the styles, if you check, there is a different type of styles you can choose. And for each style, if you click this 3 dot, you can basically define I was just using the default. You can define a color, you can define the legend. I think the default is not blue, so this is my customized color. I like to use blue as a minimum, yellow as the high maximum value to have this range of colors. And then you just simply click update. Okay, that's it. It will just compute every single surface you selected and then use this legend to label, to illustrate what are the solar radiation values. Okay, really, really simple, straightforward. And from here, you can, if you refer back to my lecture notes, right, you can actually generate this type of heat map easily, right, from the different elevation. So here, if I'm interested about, the south, I can switch to the south, and you can see the, the pattern here. Or I can switch to the different orientation, right? So you can get the color easily in this analysis. All right. So this is about the massing, really fast. That's the one I would recommend to do. Okay. Any questions so far?
How does this interact with things like glass and other stuff that the sun can go through? Does it know and like or is it gonna treat the glass like an opaque surface? Does it actually understand the glass and understand how it would go through it?
In the massing model, no. There's no properties related to the material. But in my next step, I'm gonna show you if you have a detailed model with glass, right, or mooring system, it will be respect in this solar analysis. So let me do that really quick. Imagine, if this is the wall, let me just punch a window there. A couple of windows there, maybe a window here, window here. Okay, so I have some, transparent surface, right? So now, if I'm going to run the solar analysis, I will be using, selection as well. Usually, I don't want to do this for the entire roof surface because sometimes depends on the level of details you have. This could take a long time to compute. So usually I will do a selection. I don't need to. Yeah. So here I will just pick up my selection here and then click finish, right, to finish. And then I will do updates. Okay. So as a result, you see this a little bit different from the massing. It does respect the window. Okay. Right. You see the, it has a different kind of impact to the solar radiation. But also you got this kind of, yellow color on the top. This is something, it could be really slow if you have like hundreds of walls, right? They all need to compute the solar radiation. In my opinion, this really depends on your design strategy. If I really, the only thing I care is about this roof and maybe this wall, right? This is the only two surfaces I cared. And later I'm gonna design a building skin system, maybe a panel system responding to this, heat map. So I will just pick up these two surfaces, click finish, click update. Oh, actually I deselected. Interesting. Let me just make a selection again. Yeah, I will deselect first, then pick up these two, finish, update. Yeah, so this is the only two surfaces I cared about, right? And then you can, capture this into Photoshop. Then later you can bring that into Grasshopper. You can generate some really cool paneling system, right? Another way, if you don't want to, bother to create this level of details like window, you can get a rough idea. Now, let me just delete. Oops, I want to actually just delete the window, not the wall. Okay, let me just close this. So for the wall, you can edit profile. So you will have a big window there, but you don't want to create like a mooring system or the window frame. You can just simply draw these big openings. So there is an opening there. So now if I run the radiation, we go to analyze solar peak. Right, there's two surfaces. They are still being selected. Finish, update. Right, you see the pattern is different, right? Because here you have a big opening. Right, so for the Revit to compute, this opening is much quicker than compute windows. That makes sense. All right, so I hope you guys still have your massing model, right? This is a part of the exercise we did in the first week, right? So if you still have your massing model, you can just pick up your massing, then you can run the whole analysis. If for some reason you don't have the massing model, you can still do it, but you just need to identify the surface you cared, right, to run the solar. So maybe the facade, maybe the roof, but you don't want to do the interior wall, which is irrelevant to this simulation. Any questions? Far so good. All right. By the way, there's also a lighting analysis. I don't want to demo in this tutorial. You guys could figure it out by yourself. It's pretty straightforward. You can set up window, then it's calculate the daylighting for you. All right. So what I really want to talk next is this energy analysis. These additional tools available. This is mainly trying to answer, like, if I have this heat map, right? If I want to bring that into the Grasshopper or other Dynamo parametric workflow, what are the general percentage of openings I should choose? Shall I do 0%, 100%, 50%? What's the difference? Okay. Of course, we are not really design the panel system here, so we just want to get a rough idea about window wall ratio, right? That's all we care. So I would recommend you do this as a separate file instead of using the current one. The reason is when you run this energy model, Revit will create analytical energy model on top of the current one. Sometimes it could mess up the color of your original, which you already have the solar analysis result, right? So I would prefer you save your file as a different name and do it. But I will just using this one to demo, so you can see the issues you might encounter later. So here I will go ahead, create energy model. The same thing, I'm gonna using two set of geometry as demonstration. The first one is a massing model. The second one is a detailed model. Okay, so let's start with the massing model. Create energy model. Right. If you click, basically, since I have this selected, you'll see the model will be split into different zones. Right. Let me just delete this so you can start from beginning. This is your massing model. If you select, just make sure the massing model, you do need to create floors, right? The reason is analytical energy model need to have an enclosed volume, right? It's not area, it's volume. So this volume has to be kind of sealed with roof and the floors. So it depends on your massing. If you have a skyscraper, make sure you're using the massing floors, and you want to check all the levels you want to split your skyscraper, right? Otherwise, the zone is not correct. All right, so here I will just already did the massing floors. Then I'm ready to do the analytical model. So go here and I click, right? It create analytical model. If I switch from hidden line to shaded, you can see the color is a little bit different. But maybe it's easier to just keep as a hidden line. See, it's break into zones, right? So you're done with the analytical model. Then I will go ahead generate this model. This is basically prepare further details for some analysis. Before I create generate, usually I will go to the energy settings first, which is this button. And this is a place you can define the details, such as it is a new construction, which level is associated to the ground. Other options like what's the target percentage of glazing. So you can set up this, but the most important one is actually the type of building. So for example, I can set up this as a residential, but you could also set up as hospital. This will impact the energy cost, right? How much energy is consumed depends on the different type of building. You can also break down into details like is this like a full day facility or is a half day. You can play with these details, right here. This will be important when you calculate heating and cooling, right? If the building is only used half day, winter time probably you don't have to heat up in the evening. So there are some variables you can play with. All right, I will just click OK because what I cared about is only the the window wall ratio and how that's going to impact my energy cost. You can also play with other values. For instance, the target glazing, like openings, but I would just keep everything as a default. Okay. So that is the settings called energy setting. Right. So if I'm ready, then I will go ahead, click generate. When you push generate, you see the model has been updated to reflect all the settings you have. And then you can ready to push this into Autodesk Cloud. All right, so all the simulations actually handled in cloud, which is really nice. You don't really have to, oh, sorry, wrong button, this one, optimize. So it's uploading the model into Autodesk Insight. Usually it will take about 10 minutes, 15 minutes to compute. All right. And you should have an email sent to you and say, hey, the model is ready for you to take a look. All right. So this is the button called optimize. Instead of wait 10 minutes, I will just show you the model I tested yesterday. So here, if I go to this one, okay, it's loading. Actually, this is not the one. So this is yesterday. Probably I didn't save that one. Interesting. Maybe it's here. Yeah, that's the one I tested yesterday. All right, so you can see this massing model, right? And here is about 45 US dollar per square meter per year. So that is a energy cost for this entire massing model. And if you further go down, you can see some details. This is the part I like to talk more, window wall ratio. We covered this a little bit the other day, but it's good. Let's talk more. So I'm really care about the west facade. So here, if you go to west, right, western walls, you can see here is my current ratio because I don't really have any window, right? So this is 0%. It's totally opaque. And from the energy cost, this is the most efficient one, right? There's no much heating, cooling needed because it's a black box. But the question is, do you want to accept 0% opening? Probably not, right? Then you can think about, well, if I have like 50% opening right here, my energy cost, right, will be different. So you can see there's a higher values here. Okay, so this is the kilowatts per square meter per year, right? So that's some ratios you have to check out a good balance. In general, the higher opacity, you will spend more money to maintain the temperature. Okay, so that is on the west. If I check, let's say the north, right, you can probably see a very similar pattern, but the slope is kind of flat, right? So it does have some impact, but not as significant as the west. Right. So this is what I want to show you is the percentage of window to wall you should play with. In general, I think 50% less or less would be a preferred way. Okay. Especially for the west facade. All right, so I think that's a quick demo for the energy model. As you can see, once I send out to the energy model, right, the color disappeared, the heat map disappeared. It's just because you have two models overlapping each other now. You have energy model on top of your 3D model. So if you want to see the original color, you have to delete, right, this energy model. Then you run this solar analysis one more time, it will show up. Finish, update. Okay, so that is about the energy model for the massing. Then let's talk quickly about energy model for highly detailed building, right? So for example, I have roof, I have wall, I have window. How can I run the energy simulation here? It's not a massing anymore. As you can see, this model, I actually created the floor as well. So this is actually the floor at the bottom, right? If you recall, we'll have to create a volume, like a sealed 3D volume. So you must create something like a floor. Otherwise, it's not an enclosed volume. Okay, so I have a floor, I have wall, I have roof, everything is there. And also important thing is if I switch to my level 1, right, you can see I created a roof, a room to this space, right? This is available here in architecture. You can create a room. When you create a room, make sure if you click the drop down, the room should include volume as well. So it's area and volume computations. Make sure you choose this option, right? So you do both area and volumes. And then you can drop a room into this space. And also I created a section. So here in the section view, if I switch to my section view, you can see in this section view, I think by default, the room is not like the full height of the space. It's something like this, right? This is the volume of your room. So you have to manually drag this up to make sure this is covered the entire volume of your space. Right? We can call this as zones. The zone is set up all the way to the roof. Okay, so this will be a very important step. Then I'm ready to run the energy analysis. Right. So here I can pick up this entire building. Then let's go to analysis, analyze, create energy model. And then I will, I think it's already done. Then I will go ahead, click generate. Right. Once you generate, you can see this is actually being computed. It's hard to tell the color though, but believe me, it's already being converted into an energy model. Okay. I wonder if I can really see it. Yeah, never mind, I think it's already there. Just want to make sure. Yeah, and then you are going to just click optimize, right? Then it's pushing this model again to the cloud. Same process as the massing. and you need to wait 10 minutes. And after that, you give you a full report. So here I can show you how this looks like. All right, you can see this is the, the building. Yeah, for some reason it generated this wall as well, but it's not an enclosed space, so there's no energy simulation there. But for this one, you got the whole number, right? It's $26 per month per square feet, per square meter, per year, sorry, not per month. And also you have this ratio, right? So you can see the number is not probably ideal. I can check the, let's see, what's the orientation of this? This is probably west and south. So let's check really quick. South, west. Okay. Right. You can see the window is 2% of the wall. So it's pretty efficient. Right. So even you go to 0%, it doesn't save you much money. Okay. If I check the south, yeah, I got 5% opening. Again, even I going up to 15, 30, 40, right? It doesn't really increase too much about the cost. So I guess if you want, you can go all the way to maybe even 65, right? Without seeing an increase of energy. Not significant increase. Yeah, I guess that's all about the wall, the window wall ratio, the range you guys can play with. Just understand the relationship between energy cost and those values. All right, I think that's it about the inside analysis with energy and solar. Any questions? It's all good. All right. Yeah, just make sure you play with it. As I mentioned before, it's a good idea to save as a different file name. Then you can go ahead and create energy model. When you do that in energy settings, oh, sorry, I forgot actually one thing. In the energy setting, you need to define the mode. I think I forgot to do that last time. When you define the mode, you can choose conceptual massing or use building elements, right? So in this case, if I want to run simulation for these building elements, I should choose this option. Yeah, sorry, I didn't do that right last time. So now you can go ahead, create an analytical model, right? You see this is all sealed as a volume, right? Yeah. So this is very important. I forgot to mention in the setting, make sure you set up the correct one, right? Either the conceptual model or building elements. And you want to delete the original one if something goes wrong. Don't be panic, just go ahead, delete. So it's gone. Then you just recreate. Right? So this time, oops, this time I want to use, oops, keep clicking the wrong button. I want to use the conceptual, I want to use the building envelope with building elements. Click OK, then you create, it will show up. All right, any questions?